Today we're going to be looking at some special factoring patterns. For number 1, we've got 9x squared minus 16. So you want to recognize that that is the difference of two squares pattern, which is a squared minus b squared, and that factors as a plus b times a minus b. So really all I need to do is factor the 9x squared and the minus 16. So I get 3x and then I get 4. So one will be a plus 4, the other will be a minus 4. The order does not make a difference there. And again, you could always box or FOIL that out to make sure that you did factor that correctly, and you would see that then when you multiply those together you do get 9x squared minus 16. Now number 2 here is, it doesn't look like a difference of squares pattern, but that's because there's a common factor of 3 that we can take out of that. When we do, we see that we have 49a to the 4th. Oops, let's sneak the 9 in there. 49a to the 4th minus 25b squared. So once we get that common factor out, then we can see that we do have some perfect squares there. And so we square root those. Now when we square root a 49a to the 4th, the result is actually a 7a squared. And then when you square root the 25b squared, you get a 5b. And so of course one is plus, one is minus. Oops. Minus the 5b there. And so that's what that factored form looks like. And again, you could multiply that back out, make sure that that does give you the original, and certainly it does. Now for number 3 here, we've got a whole polynomial. Notice that the 16x squared and the 81y squared are perfect squares. Now, in order to check to make sure that that fits our pattern, which is the a squared minus 2ab plus b squared, and that factors as a minus b squared. To make sure that it fits the pattern, we square root the 16x squared. That gives us 4x. We square root the 81y squared. That gives us 9y. Now we find that product and we double it. So that gives us 36xy. Double that, we get 72xy. That has to match the middle term there. So it certainly does, the 72xy. So then we know it just equals our factored form, 4x minus the 9y squared, just like that. Alright, now number 4, we have just two terms, and the y cubed is a strong indicator that we would have a difference of cubes here. And certainly if you look at the 216 and 343, those are perfect cubes. So we use our perfect cube, or sorry, difference of cubes pattern, which looks just like that. If we have a cubed minus b cubed, it factors as a minus b times a squared plus ab plus b squared. So really what we do is we cube root the two terms that we have. 216, if we cube root that, we get 6, and then the y, and then 343 becomes a minus 7. Now it's very nice that really the 6y and the 7 are kind of our base units for then our trinomial. To get the first term, we just square the 6y, which is 36y squared. The middle term is just the product of those two. Notice again the sign change there in our pattern, but we get 42y. And then the third term is just what we get from squaring the 7 in this case, so in this case 49. And so then that's how we factor that. Now this trinomial here looks maybe fairly factorable, but that will not factor unless there is a common factor in here that you forgot to take out. But otherwise this does not factor at all. So you're done at that point. Number 5 here, again we've got a common factor kind of hiding some information from us, where really once we take that common factor of a 2m out, we'll see a bit more clearly exactly what we're dealing with. Specifically, we've got a 125k cubed minus 27m cubed. And with that one, again, the special thing there is that now the 125k cubed and then 27m cubed, those are perfect cubes. So we've got that difference of cubes pattern again that we just had to deal with. And this 2m is just going to kind of go along for the ride. So if I have the 2m out here, I cube root the 125k cubed, that gives me 5k, minus the cube root of 27m cubed, so 3m. And then again, that 5k, all I have to do is square that in order to get my first term here, so 25k squared. And then plus the product of the two terms together. So 5k times 3m be 15, and km or mk does not make a difference. And then we square the 3m for the last term, so 9m squared. And that's all there is to it. Again, make sure again that you remember that 2m there at the beginning because we took it out earlier. Number 6 is actually a difference of squares pattern, that a squared minus b squared factors as a plus b times a minus b. And again, it's the 25 and the 16 that are the key there to figuring that out. Of course, b to the 6th, still a perfect square because 6 is divisible by 2. So really just square root both of those terms to get our different pieces that we have. So we'll start with a 5b cubed and then a plus 4 and a 5b cubed minus 4. And again, with the higher degree, you've got to double check, make sure that you don't have anything else that can be factored, but certainly neither one of those factors any further. All right, looking at number 7. The 49y to the 6th and the 36, again, lead us to believe that this would be a perfect square trinomial. So it would have to fit this pattern, where, again, that middle term is the product of the square roots of the two first and last terms. So if I square root the first term, I get 7y cubed. Square root the last term, I get 6. So I find that product and double it. So then I get 2 times 42y cubed. Double that, of course, I get the 84y cubed that we're looking for. So again, confirmation that yes, it does fit that pattern. Once I know it fits that pattern, I already figured out the 7y cubed and the 6. Those are the two terms that go in here. So the factored form just turns out to be 7y cubed minus 6 squared. All right, final one, number 8. Again, the 8z to the 6th minus the 343. That, again, is a pair of perfect cubes. So it fits this pattern, the difference of cubes pattern. So really I just cube root those in order to get started. So in this case, cube rooting 8z to the 6th gives me 2z squared. And then cube rooting 343 gives me 7. And again, the nice thing about this pattern is that the 2z squared minus 7, that really holds my base units for my trinomial. So the first term in my trinomial, I square the 2z squared. So that gives me a 4z to the 4th. The second term in my trinomial is just the product of these two terms together. So I'd have a 14z squared. And then the last term is just squaring the 7, so 49. And so that's the factored form for that. And again, remember, this is going to look factorable, but it will not factor at all unless we maybe missed a common factor up here, which we did not do. And so that's it. So again, those special factoring patterns, even as you're working through these, if you write them down, that will help you remember them. And notice the similarities between them. That can make remembering them a bit easier. So best of luck with that.